We're going to talk about some angles today. You will need your protractor if you have, so if you want to grab that so you can easily access that, then that would be wonderful. But before we start with the protractor, let's talk about some angles and some things that make up angles and some new terminology and vocabulary. And I'm sure you're real shocked to hear that there is even more vocabulary to learn. Let's talk first about what we call a ray. Okay, so a ray is a line segment that goes on forever in only one direction. Okay, that's the best way I know to describe it. It's actually a part of a line, right? So a line that has an endpoint. So let's say this was MOP. So the way we name rays, because remember it's really important in geometry that we are naming our geometrical figures correctly. So this could be named ray, and this is where your order does matter a little bit. You always want to start when you name endpoint, so I want to start with M. So this would be ray MO. And I do this little symbol on top, and I only take it in one direction. That tells me that M is the endpoint, and it goes off in the direction of O. Okay. I could also name this ray MP in this direction as well, right? Okay, so there's my ray. Opposite rays, and if you think about it, it really makes sense. Opposite rays make, can you guess? What do they make? If I have this ray, and then I put a ray in the exact opposite direction, guess what I have? Come on, pen. If you said line, then you are correct. Opposite rays make up a line. Okay, so let's talk about an angle. And you very well may already know this, but if you don't, that is okay, because that is what I am here to teach you. So an angle is made up of two rays together. Okay, and we'll give this some names here. Let's say this was Y, X, and Z. And we'll even put a number here to name the angle. So this angle is what we call angle YXZ. Now, a couple of things. This point where they meet is what we, this where they meet is what we call the vertex. When you name an angle, the vertex has to be in the middle, okay? So remember that. All right, this side is side XY. Remember how we name rays and we said that this is just two rays? So this side would be C. Okay, so we've got a vertex, we've got the side, we name the angle, and as my shorthand, a lot of times I will put a little line through here to let me know as I'm writing this that that is not a less than sign, that is an angle sign, but you definitely do not have to do that, okay? And so this is also, we could call this angle 3. All right, any points in this area, remember this goes on forever, any points here are in what called interior of the angle. Well, let me be able to tell, right? Help, right? My computer lagging is starting to impact me writing on it. Interior, which I'm sure you can guess that any of the area on the outside here is the exterior of the angle. Okay? All right. So let's talk about what an angle does and how we actually measure an angle. So we use a tool called a protractor. And let me see if I can get my protractor pulled up here. Yay. So this is what a protractor looks like, right? So what we do is we put the vertex, actually, didn't mean to do that. If this is my vertex, here's my angle, like this. If this is my angle, right, now we'll name this also X, Y, and Z. What you want to do is you want to take your protractor and place the vertex right at the crosshairs exactly, and the bottom side here, and this is terrible because this is not a straight line. Let me get you a nice straight line here. Give me just a... Okay, I had to remember where my straight line tool was here. So I've got this angle. Again, here is my vertex, right? And my size. And so what I want to do is I want to place my protractor. I want the crosshairs to be right on that vertex and this side to line up exactly with my protractor. And let's see, that looks good. And so what I'm going to do is I am going to read here the measure of this angle. Now, altogether we have 360 degrees in a circle, right? I went all the way around a circle. There are 360 degrees. Half of a circle then would be 180 degrees, and that's why this goes up to 180, all right? Here, I'm going to use this small number because the closer I get, 90 is straight up and down. That's your right angle, right? So as I get wider, it gets bigger, and as I get smaller, the number also gets smaller. So I know I have to look at smaller numbers here. So this looks like about 21, 22, 23 degrees on this angle. Just so you see how to use that protractor. Okay. All right, so different types of angles that we have. Now I got to remember how to get rid of that protractor, don't I? Let's see. Math tools. Well, no, that just gives me another one. Let's close. And then close. Okay, types of angles. So we have 3 types of angles. And I kind of touched on this just a little bit, but here we go. We have what we call right angle. And a right angle means that it measures exactly 90 degrees. Okay, straight up and down, exactly half of that 180. And we mark it with a little square in the corner and the vertex. And that lets me know that this, and we'll call this A, the measure, and this is how we measure of angle A is 90 degrees. That is a right angle. Okay. Anything less than 90 degrees, so let's have same side angle here. This is clearly less than 90 degrees, right? And we'll call this B. If the measure of angle B, come on. Oh, come on, Daisy. If the measure of angle B is less than 90 degrees. Now you see why I marked my little angle marks here. The measure will be less than 90 degrees, then it's a cute little angle. We call it acute. And the third type is, you probably guessed, bigger than 90 degrees. I bet you can't guess what I'll name this angle. Ha! Ha! Did you guess? The measure of angle S is greater than 90 degrees, then we call that an obtuse angle. So make sure you're able to classify those angles based on their degrees. And of course, these mostly you can look at. They may not be, you may have some that are kind of close that you have to protract on, but most of these will be obvious in what type of angle they are. Okay? Now, we congruent angles. And congruent angles means they have the same measure. Okay, because remember the rays are going off forever on both sides, so that's not really an issue. So we're looking for congruent angles having the same measure. And the way we mark that, were congruent segments, we marked with one line, right? So congruent angles, and they don't have to be facing the same, just degree here has to be the same. All right, so if this is angle ABC, and this is angle DEF, okay, if these are congruent, so angle ABC, congruent, remember that congruent sign we talked in a couple sections ago, to angle DEF, the way I mark it is I put one little mark here in the angle. That tells me it's congruent. Now, if you need to indicate more than one angle is congruent, you can do two lines, and that tells me those are the two that correspond to each other that are in fact congruent. Okay? One final thing before I set you loose, that is an angle bisector. Okay? An angle bisector, and bisector is a big vocab word here in geometry. Bisector means cut in half, okay? So an angle bisector cuts the angle in half. Okay, so if I have this angle, and I said this was W, X, Y, and Z. If I told you XZ is an angle bisector of angle WXY, that would tell you that, so I'm going to say, therefore, angle WXZ, now look at what angle I'm talking about, WXZ is congruent to angle ZXY. These two angles are congruent. Okay? Now, as you work through these problems, understand what that means. You may encounter a problem that tells you, oh, this is 2x plus 3. This is x minus 5. What's the value of x? And of course, here we would just set the equal and solve for it.